this is Miss Litton, and this is my Period 4 Honors Bio class. Say hi.
Hi.
Okay, and for all of you in the Fine Arts Assembly, we know that you are doing an awesome job. I record these and then I put them on my YouTube channel.
Video?
What?
Just video or just audio?
It's going to collect the screen only. If I try to collect me, I have to either live stream it or I film dances. But where are all the places you can see the dances? TikTok. And do you know what TikTok is?
Yeah.
Okay, and so, I don't know. I didn't know till, this school year. Anyway, so those are all there for them to watch it if they miss like a review or a class. Yes, exactly. Okay, so we miss you and we can't wait to see you be fine arty. Okay, now, a couple things I want to review. Let's start with the circulation of blood through our body. So here we go, ready? Arteries go away from the heart, veins go towards. Arteries, arterioles, capillaries in the middle, venules, veins. Heart, body, heart, lungs, heart, systemic, heart, pulmonary, atria, collects, and ventricles pump. Valves keep the blood flowing in one direction. Okay? Are we good on that? Okay. Then we have our little Tai Chi, yes? Okay, so let's start at, where should we, let's start at this so we can mix it up a little bit from the way we learned it, but still know how to do it. Let's start at the left atrium. You there? Now think through, I'm not going to do it yet, but think through what the next steps are. Don't show it with your hands, just think it through. If we're starting at the left atrium. And remember, you can see this Tai Chi-ness on TikTok, it's there. Okay, you ready? Here we go. Where are we going to go if we're at the left atrium?
Left ventricle.
What? Oh, yeah, left ventricle, yes. Then out to the lungs. Then we're going to come, is that right? No. Okay, go again. We're at the left atrium. We go to the left ventricle. Where are we going to go? To the body, right? Because our blood is oxygenated, yeah? Goes all around our body. We come back in the right atrium, right ventricle. Now where do we need to go? The lungs. And come back. We'll do this silently. See how we do? Okay, now, what I want you to talk about with your bio buddy, because I'm thinking forward about what we need to talk about, when you're going out and back to these different places when you're Tai Chiing, identify, is that oxygenated or deoxygenated blood? Go ahead. You know what, sweetheart, come right here. She needs bio buddy. You're going to trifecta. Yeah, okay. All right, talk about that right now. Oxy, deoxy, what is it? Okay, you ready to try it together? Let's start at the left atrium again, and we're going to say oxy and deoxy, like as we're exhaling. Okay, here we go. So we're in the left atrium. What? Left ventricle. What would this be? Oxy, deoxy, deoxy, oxy. Right? Oxy, deoxy, deoxy, oxy. See? Beautiful. Okay, which of the three vessels is the most muscular? I only had like 3 people tell me the answer. What do you think it is? Arteries. Why? Because arteries go away from the heart. So they have to withstand the pressure of the heart, right? What makes blood move through arteries? Really? Valves are like, go blood, go blood. Think about it. I appreciate that input. It keeps it going in. Valves keep the blood going what? In one direction. But what makes the blood move in an artery? The heart. Right. What's the strongest part of the heart? The left ventricle. okay? The ventricles are stronger than the atria, right? Because when the atria contract, they collect, and when they contract, they only have to push the blood down into the ventricles. That's not very far. It's like upstairs, downstairs, right? But the ventricles, when they contract, they're either sending it all the way out to the body. That's why the left one is so strong and thick, right? Because it has to go all the way out to the tip of your head, to the bottom of your toes, and through every organ in your body. But when the right ventricle contracts, it's still hard, but it only has to go out to the what? Lungs. Okay? Where does all exchange take place? Capillaries. Why can it occur in the capillaries? Did you say one cell thick? Yes. And today we're going to touch base of the little dance that happens at the capillaries. We're going to visit that today. Which one has valves? Veins. Why did only one person say that? Valves keep the blood flowing in one direction. Do you need to worry about the blood flowing in one direction in an artery? Yes, no, why? Why do you only need valves and veins? Discuss with BioBuddy right now. Discuss it. Own it. Okay. What keeps the blood flowing in arteries that go away from the heart? Heart contraction, yes? I want you to say that with authority, right? We need to know that. The reason why blood moves through your body is due to the pump. The pump's name is heart, yes? So it pumps, forces blood out through your arteries. Why does the blood come back to the heart? If you're thinking about your toes, gravity is saying what? Go down, Moses. That's what it's telling it to do, right? We need it to go up against gravity. Part of that is going to be due to the blood coming behind it, but also what assists it moving forward are those what? Valves. So if it gets jammed, so it's like, gets pushed up, those valves will help catch it, but what even makes it move through the veins at all? The heart's keeping the blood flowing. I agree with that statement. Remember what we talked about. What keeps blood moving through your veins? Muscles. Remember muscles? Okay? That is critical. You cannot underestimate that. Okay? Those muscles, remember, the valves are like toothpaste. You take off the lid of your toothpaste tube, and those muscles are like grabbing that toothpaste. Toothpaste is only going to squirt in one direction, right? Out the opening. The only place it can go. So every time your muscle contracts, and it doesn't have to be like, it doesn't have to be that big. I almost fell down. Okay? It doesn't have to be a huge old, it's not like you have to walk around to keep your blood moving and contract your muscles all the time. You're constantly contracting your muscles all the time. It's called muscle tone. And so you're always contracting a little bit. When those muscles contract, the vein walls, are they thick or thin? I'm not saying, the answers have been given, but very few of them have been given. Thick or thin? Thin. Who has the thickest walls? Arteries. Why? They have to withstand the pressure of the heart, right? Our pulse, right? Remember what our pulse is, the expansion of an arterial wall, and we're detecting that, right? And it snaps back. Yes? The veins, okay, the veins need a muscle to contract and smish it. That's a biological word. Smish it. And when it makes that smaller, the blood has to go somewhere. It can't go back where it was because there's a valve. It can only move in one direction. Yes?
Is this the reason why when you get a bruise or something, you get injured in your leg, you're supposed to keep it elevated?
Yes. Yes, absolutely. Keep it elevated. Because you're trying to assist the drainage process.
So like it would be hard for the muscles to contract and get the blood back to the heart? Is that why?
Yeah, but you're going to have swelling due to part of it will be your immune response going, we have damaged tissues here, okay? Histamine will end up getting released, and so you're trying to help with that flow to get it back because gravity is going to pull that fluid down, and if it's in your capillaries and in your vessels, you can control that, but if it's out in the fluid of your tissues, that would be harder to control. We'll talk a little bit about that today too, and also when we talk about the immune system. Okay, now, I need you to take charge on this and own this information. I need the oldest bio buddy to describe why does blood move through the artery, and I need the youngest bio buddy to answer why does blood move through your veins. Go. Okay, so if I was going to pick one word, I could only pick one word to explain why blood moves through my arteries. What would that one word be? Heart. Exactly. If I was going to pick one word to explain why blood moves through my veins, it would be hard to pick one word. I think I'd have to pick two words. Muscles and what else? Valves. Exactly. Because it's not, and then you would have to help people understand the misconception. It's not the muscle of the vein itself, right? The vein doesn't have much muscle. Remember how thin-walled they are? It's the muscles outside of the vein when they contract and push on the blood. Does that make sense to you? Yes? No? Ask your bio buddy, how are you feeling on everything we've talked about so far? Are there misconceptions? Are there hard parts to it? Everything we've done so far in our group shared notes. Look and talk. Go. Okay? Clarifying questions. Let's see, this might be your misconception too, or confusion, so yes.
So when you get like cramps sometimes, is that
Cramps like period cramps or muscle cramps?
like muscle cramps?
Yes. Do you want me to explain that?
Affect it, like would it make it worse or better?
Usually those muscle cramps are the salts are off in your body, right? You know when they tell you like you're trying to avoid muscle cramps to eat bananas. It's the potassium that you need. Usually you are not having the right ions in your body, and so your muscle will do that in relationship to that. Yeah. So it's a matter of what you're eating, making sure you get all your salts. That's why they sell those really glucose-fueled drinks, right? If they just had the potassium and some of that, maybe this little sodium or something in there, that'd be great. But yeah, they put a lot of sugar in those drinks too. Will sugar give you fuel? Yeah, absolutely. Sugar will give you energy. But that's like building a campfire and wanting to roast a steak and building your campfire with paper instead of logs, right? That's the difference. That sugar burns fast and hot and furious, but not for the long haul. You want to burn the fat. That's where you really get the good burn. Okay? What else? Other clarifying questions? All right, we're good. I'm going to show you a picture. Wait, do you have a question? Go ahead.
For the veins, the reason that they go back to the heart is to get the oxygen from the lungs eventually, right?
Yeah, well, the veins' job is to always bring blood back to the heart. They could be bringing blood back to the heart from your systemic circuit, right? Or they could be bringing it back from your pulmonary circuit. Their job is back to the heart. Arteries away, veins towards. That's their job. So it depends on where they're coming back from. Yeah. Anything else? These are all good questions. All right, sweet. I'm going to show you a picture. I am anticipating that you will understand this picture perfectly from what we've done. Remember your Tai Chi when you look at this picture. And I would like the longest haired bio buddy to take the lead on that. Longest haired. You're going to have to just decide, okay? We're not getting any rulers. You're just going to have to go with it. I'm not going to be the arbitrator. Figure it out, okay? Here you go. You gotta shoot a hostage. Okay, now, this circuit right here, what part of the circuit is this in our Tai Chi? Show me. It's this all the way out and all the way back. What part is this in our Tai Chi? All the way out to the lungs and all the way back, right? Okay, now, that was easy peasy, yes? And why is there one color blue? What is that to represent? And is the blood ever blue? No, absolutely not. Okay. Now, short-haired bio buddy, it is your turn. Here you go. Go ahead, short hair. Okay, so now, easy peasy. Now, I want us to name the chambers and oxy-deoxy because we're going to take notes on it, and I don't expect you to already know the answers to those notes. We're going to start now in our right atrium. You there? So it's right atrium, what? Right ventricle. Oxy or deoxy? Deoxy. And then what? Oxy. Now where are we? Left ventricle. Oxy. Deoxy. We're back in the right. Now you say it in your head. Inside voice. Good. Okay, let's write about it. Look at your notes. Oh, sorry, you can't see us Tai Chi. So go to something in your notes. Go to the vascular pathway. You there? What's the first circuit on there? Pulmonary. Are you imagining a pulmonary circuit in your head right now? Good. Pulmonary arteries carry what kind of blood? Pulmonary arteries. Arteries go away from your heart. So what kind? Deoxygenated. Good. Deoxygenated blood. We have the exchange of gases at the capillaries, alveoli, at the lungs. At the lungs. Now let's talk about that. Remember, the scientifically illiterate person is going to think that the lungs are just two big bags, right? But that's not the way your lungs are. They're made out of millions of little air sacs, right? And why do we want to have millions of little air sacs? What does that increase? Surface area. And we have higher surface area for all of our what? Bless you. For all of our what? Exchange. Okay? That's what alveoli are, the millions of little air sacs in your lungs. Okay? Then let's look at the next part. Pulmonary veins. Think about your Tai Chi-edness. Right? Arteries go away, veins go towards. What kind of blood are they going to carry? Oxygenated. It is so much better for your brain if you logic it out and understand why it would carry that instead of trying to what it? Memorize it. Okay? So you have a finite amount of things some of you can memorize. So it's better to understand it. Then it doesn't matter what kind of question I give you, you'll be able to figure it out, right? Okay, then the systemic circuit. It starts with the largest artery of your body. What is that? Largest artery. Aorta. Somebody needs to study the heart a little bit more. Starts with aorta, and arteries carrying what kind of blood? Oxygenated. You have the exchange of gases, nutrients, and waste at the capillaries of the tissues. Systemic veins carry what kind of blood? Tell your bio buddy, what kind of blood do systemic veins carry? What did they say? And they were right. Deoxygenated. All right. Now, next thing. True or false? Your heart is a muscle. True or false? Your heart needs oxygen and nutrients. The heart could probably get all that it needs through the blood flowing through it in the chambers. Riddle me this. Where does all exchange take place? Capillaries. How many cells thick is a capillary? Okay. How thick is your heart? Very thick. So could all exchange take place with the fluid that's just in the center? Could it like diffuse through all the thickness of that muscle? No. You wouldn't need capillaries if that could happen, right? You just have like a big old blood tube going by and it's like, let's move it, okay? They can't go through all that tissue, right? They can't diffuse through all that tissue. It's just too much, right? Is my voice diffusing into the other classroom? No, it can't, because there are layers and layers and layers of that wall. But if the classrooms were divided by a sheet we hung up, could my voice get through that? Yes, because it's very what? Thin. Same thing. So when you have blood moving through your heart, that's not going to feed the heart muscle. And that is one muscle that you better not skimp on. Okay? So it has a whole circuit of blood vessels, of arteries that feed it, and veins that take waste and CO2 away. And that's your coronary circuit. Anytime if somebody says, don't have a coronary, if you've ever heard that, that means don't have a heart attack, right? Coronary is always heart. And so it's very important that you feed it. If, let's say, you are eating the wrong kinds of food and you have a blockage in that, hashtag good, hashtag bad. Bad, exactly. This is where you go harvest a vein, maybe from out of your leg, and you borrow that vein and you do a workaround, kind of like if there was a traffic accident on the freeway and it's like such a mess that they take everybody off the off ramp and then past the accident they bring you back on. Okay, do you know what that would be called? A bypass surgery. A bypass surgery to work around what's been blocked. Take a look at this picture and see what kind of bypass do you think, because a lot of our presidential candidates are old white men, right? That's hashtag truth, okay? Some of them have talked about this particular surgery, okay? What kind would this be right here?
Sorry, so you said that like the vein comes out of your leg, right?
Yes.
So what happens to your leg?
They'll use other veins in order to they'll junction it up. So talk about it with your bio buddy. What kind of surgery do you think this would be called? How many bypasses do you see? Count them. 3. So what could we call that? A triple bypass. A double bypass would be when you only had 2. So you have 2, I think they have stents. I can't remember. Is it stents? Yeah, they just have stents. Stents is scaffolding. It's so you don't have to do this. Stents are scaffolding where they're like, it's blocked, so we've got to open it up, get the diameter a little bit wider. Remember we talked about cholesterol and blockage? So what they'll do is they put scaffolding in there so that the blood can get through. Okay? So that would be to avoid that, because that would be kind of serious. All right, now back. Let's go to our notes on the coronary. Here we go. Your coronary circuit serves the muscle. What muscle is that? Heart muscle. Perfect. All right. Now, let's talk about food for just a minute. We have not learned this system, but what is the system that handles our food primarily? How do we get food into our body? We eat it. It goes through our mouth. Where's the next place it goes? Yes, the esophagus. Good. And where does it go after that? The stomach. Good. Okay? So it goes into the stomach. Now, where does it go after the stomach? Small intestine. And then after the small intestine is the then the rectum and the anus. Okay? Now, there are two types of digestion, mechanical and chemical. What do you think your teeth do? Exactly. It rips it apart physically. It makes the particles smaller. The smaller the particles, you increase the surface area for enzymes to work on. Okay? Now, there's another part of your body that does mechanical digestion, and that is your stomach. In fact, when you are hungry and your body senses, I am low on nutrients, then it sends a message, and your stomach's like, I want to get ready because I know I'm going to get some food in here pretty soon. So it starts contracting to get ready to do some mechanical digestion. If there's no food in your stomach, it's going to push air around, and what's that going to sound like? My stomach is growling. That's your stomach saying, feed me, okay? And so it's getting ready. It also does mechanical digestion. Chemical digestion is using enzymes. In your mouth, there's something called salivary amylase. It digests starch. In your stomach, the only thing that gets chemically digested in your stomach are proteins. That's it. So I've done carbohydrates, and I've done what? Proteins, okay? But I'm not even done. I just started the process. I'm not finished yet. So the bulk of all your digestion and all the absorption of your nutrients occurs in your small intestines, okay? Occurs in your small intestines. Now, if you've just eaten a meal, let's say this morning for breakfast, you had a Cinnabon, an omelet, some orange juice, some toast, some oatmeal with brown sugar, nuts, raisins, okay? If you ate a big breakfast, okay? If you ate that big breakfast, then the blood around your small intestines went, right? Where does all exchange take place? Capillaries. The capillaries are going to be picking up a lot of what? Nutrients. What if you ate nothing and you haven't eaten anything since dinner because you're not somebody who gets up in the middle of the night and eats? I would not start that strategy, okay? So let's say you haven't eaten anything since dinner, you had no breakfast, you had nothing in nutrition. The blood, the capillaries around your small intestines are going to be putting what? Nothing in there. Nothing in there. So the blood sugar level or nutrient level of the capillaries around your small intestines, sometimes it's high and sometimes it's low. So this amazing thing happens. Normally we go what? Say it real fast. Arteries? No, second verse. Arteries. There's 3 places in your body where it does this. Look. What did I just insert in there? Not 1 set of capillaries, but 2. Let me show you where that happens. This is a super smart thing about your body. Look right here. Here's the blood going to your capillaries. At the capillaries, they're going to either pick up nutrients or they aren't going to pick up nutrients. It's either there or it isn't there, okay? Either way, the blood gets shunted immediately. It doesn't go back to the heart and go get in the pulmonary circuit. It immediately gets shunted over to, can you tell what that is right there? The liver. And if it comes in hot, full of nutrients, what's your liver going to do? Store. It'll store those nutrients in your liver for later when it comes in not hot but cold. And I don't mean temperature, okay? So it'll store it. What if your liver says, we're all full here. You had a Cinnabon, toast, orange juice, jam, omelet, and oatmeal. We're all full here. What will the liver do with those excess nutrients? It will convert it to what? Fat. And you'll store it out in your fat cells. There is no fat on your body that's old. There's no old fat on your body anyway. Okay? You are constantly putting nutrients into your fat and pulling nutrients out of your fat. If you have a lot of fat, that means you're eating more than what you need, so you keep storing it. Does that make sense? So you can keep pulling from it. So your liver will store it as fat. If the nutrients coming in are low, like because you haven't eaten, what will your liver do? It'll put nutrients in. Your liver will help moderate your blood sugar level. It'll put nutrients in if it comes in low. It'll take nutrients out if it comes in high. What if the blood coming into your liver from your intestines is low in sugar and the liver doesn't have any sugar. Where can it go get those nutrients from? Where did I tell you store it? Fat. It'll go get it from the fat. Okay? Can you also burn protein? Yes. So a good source of protein is your muscles. You know when you see those starving children in Africa and they have this bloated stomach? Is your first thought they drink too much beer? No. Okay? They're starving. They're little skeletons walking around with a bloated stomach. Do you know what I'm talking about? Okay? The reason is they have no food, okay, or very little food, and so they don't have any fat because they burned all of their fat. The first muscle to go is your abdominal wall. And so they start digesting their abdominal wall muscle in order to get nutrients. So if you don't have an abdominal wall, all of your gut is going to do what? Just like this. Okay? That's where that comes from. So you will pull, like anorexic, I've had anorexic students that I have visited in the hospital. They're like walking skeletons. There's a woman on my way to work every day. If you come from Wood Ranch, she runs the hill up there if you come before 0 period, and she like goes like this. She's like a little stick figure working her way up the hill, and I just want to like throw burritos at her. But your body, if you don't provide it with enough nutrients, it's going to get it because it for sure has to keep your brain functioning and your heart functioning. So it'll just take it from your muscles, and your muscles will just waste away. Okay? But the amazing part of homeostasis of our body is how those are your kidneys. Either way, if it comes in with high nutrients, you'll store it in the liver. If the liver's full, you'll store it as fat. And if it comes in low, your liver will contribute nutrients. So every time it leaves the liver, it leaves it just right. Now, anything to do with the heart, what was the word we used for anything with the heart? Coronary. Anything to do with the liver is hepatic. Okay, so this is your hepatic vein that is leaving your liver and going towards your heart. Have you heard of hepatitis? So that's a problem with your liver. Itis means infection of or inflammation of, whenever you have itis on there. Bronchitis, what does that have to do with? Lungs. Laryngitis, with your larynx, right? Okay, now, but what I want you to do is look at this picture. Something's wrong with this picture. Over just the stuff we talked about here. You should see like, wait, this is going to happen. Discuss with your bio buddy. See if you can find what's wrong with this picture. What do you think is wrong with this picture? Do you see anything? Yes.
So, to the right of the liver, so like the pathway there, it's deoxygenated blood being brought into the capillaries and deoxygenated blood leaving.
Right. So that's perfect. What isn't the liver getting? Oxygen. This is how they draw these pictures all the time, and it drives me nuts. What they're showing you here, and this is critical, this is called the hepatic portal vein. This is the port between the small intestines and the liver. They're showing you a hepatic vein, but what aren't they showing you in this picture? A hepatic what? Artery. And there is one, okay? But because they're trying to point out the portal system, they don't show you that there is also a hepatic artery there as well. Okay, so they're just doing a bad job modeling the circulatory system when they do that. Okay, but you know it's got to get oxygenated blood as well. Okay, let's write this down. Okay, go to portal system. Takes blood from the small intestines directly to the liver. The purpose is blood nutrient regulation. And how many capillary beds do we have in this loop? Two capillary beds. First one is in the intestines, and the second one is in the liver. Okay, first one in the intestines, second one is in the liver. All right, there's two other places where that happens in your body. One here in your brain, and I put that on there, I think I said pituitary gland, and one in your kidneys, but we're not talking about that right now. Okay? Now, take a look at this picture. Look at the picture on top. Look at the picture at the bottom. You're going to be in charge of explaining one of them. Not it. Okay. Whoever's taking the first picture, go. If your bio buddy is giving you a weak ass response, ask them to pick it up a little bit. Okay, go. All right, time to switch. You can absolutely do this. Go. Do not be intimidated. I want you to address something. Why did the colors change? Why is this so spazzy? Okay? Address those two things right there. Okay, why is this so spazzy? What was that? The heart. Right, the heart's contracting. So it's like, okay? That's how it is. Okay, yes.
Oh, I was giving her a high five.
Oh, excellent. High five. Good. Did she dissed you on that? Okay, now, so that's the spazzy part right here. Now I want you to follow this line. Spazzy, 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 less spazzy, because we're getting farther away from the heart. Okay, now look at this line. It's here, and it ends up right there. Because blood, just like diffusion, what is the definition of diffusion? Going from a higher concentration to a lower pressure. We'd have serious issues because blood can only move from a higher pressure to a lower pressure. So the highest pressure is coming out of your heart. Like if you went in and said, I'm going to slice your aorta, okay? You know how fast you're going to die? Very fast, okay? Your aorta would just be like, people have an aortic aneurysm, that's like death in minutes, right? 3 or 4 minutes, you're done, okay? So because the blood is under such pressure here. The lowest blood pressure of all is going to be where? You know the vessel's name. Say my name, say my name. My name is... Vena cava. My name is Vena cava, right? Vena cava is where you're returning from your what?
Body.
From your body, right? That's going to be the lowest pressure in this particular circuit. Is at your vena cava. Okay? Hardest at your aorta, lowest at your vena cava. Can you make sure your bio buddy understands why that is? Because I see some question marks on your faces. Now, let's contrast pressure with speed, okay? If you're at a raging river, and that, like the aorta, I'm going to say that's a raging river, okay? And you start branching, the more you branch your raging river, what's going to happen? Is it going to be as raging? No, it's going to slow down. Why? Because the river is going to come in contact with the bottom. And that contact, right? Remember our forces we learned about last year in physics? It's going to push back, right? And it's going to slow it down. And so it's going to slow as it gets into tributaries. That's going to be when it's the slowest of all. If you rejoin those tributaries back up into venules, and venules will rejoin into what? Veins. These are larger vessels. Less of it is going to come in contact with the surfaces. So what's going to happen? It's going to what? Speed back up. Okay, and that's why I had you look at this diagram first. Raging river, right? It's going to slow down, and it's slowest of all when it's out in the capillary beds. And if you look at this diagram, you can see that. Okay, velocity is surging due to the heart. Then it goes really slow. It's going to go slowest where the cross-sectional area is the highest. They're inversely related. So as you have less of a cross-sectional area, as they're back into those venules, then it's going to start to speed up a little bit. Okay? Now, let's see, where are we at? 11:04. Okay. Take a very quick lap. Very quick lap. Around and back. Do not be distracted by those that are going to the assembly, or they're probably already there. Quick lap. I'll see you back. Walk with authority. So period 2 doesn't need this as much, but this period does. They're at lunch, they're at a lull, and I do try to do laps, and so sometimes I'll let them take 1 lap or 2 laps, and then just take a lap around the building. It gives them a brain break, kind of reset. Exactly. Yeah, they just, I could see the energy level going to
Compared to last class, especially,
yeah.
she's, I don't know the names, but she's very,
Yes.
engaged, and everybody else is kind of.
Yeah, and these guys which choose to sit right here, they'll be the most off task, and I'm always looking at them, and then they get the lowest grades.
Really.
Yeah, and I mean.
Is that kind of a universal thing? Classes?
Some kids choose, like, they sit over on the side, that was their choice, to sit over there, because I didn't have enough seats for everybody, but they're very engaged.
Right.
But these, like, they're not as strong as students, just so happens in this class, he's sitting right here, so I have to work him a little bit more, and chew, like, I had to chew on him, because he was totally off task, like, a week ago, and he was playing a game when I told him to focus, so I had to rip him a new one, and then I ripped him every single day for 3 days after that. So it's sometimes they need that, and you're like, I'll just tell them, you're not surprised, right, that you got a low test score?
Right.
Because you don't contribute. I don't do it like I'm taking it personally. I'm just
Right.
like, well, it's natural, right? You didn't really work that hard. And I'll just be real straightforward with them. You don't really work that hard in class, so of course you got a low score. You're not surprised, right? And I'm just real, like, natural consequences. If you choose not to be here, that's on you, right? I have kids who will come in sick as a dog because they want to be participants in the class, and they know, like, I give very little homework, and they know we're game on. I am a bell-to-bell teacher, so we're on from the beginning to the end, and I don't need to give a lot of homework because they learn it here in class. Yeah.
It seems like they're, these kids have to be more
Yes.
motivated than the.
Yes, and it's math tracking. When you come sit down, try to figure out the picture that you're looking at. As you're sitting down with your bio buddy, try to figure out the picture. Try to figure out the What is this thing in the middle? Perfect. It's capillary bed. What did we say happens at all capillary beds? Exchange. That's the part I want to teach you right now. Okay? Dial it in. It could be hard, maybe not. Depends on how your brain's working today. Okay, but dial it in right here. I'm going to ask you a couple questions to set you up. We already talked about it, so this should be a review. Where do you think your blood pressure is the highest? At the arterial end of the capillary bed, the venual end of the capillary bed. Check with your bio buddy, see what they say. Okay, what's your answer? Tell me your answer. Final answer. Perfect. Arterial end. You're 100% right. Because you know your blood pressure drops the farther you get away from your heart. Okay, so I'm just going to make a little line here, like this. And what do you think that's representing? Oh, that's good. It does happen at the capillaries, but what did I just ask you to think about? Blood pressure. So what do you think this line represents? Blood pressure. So what are we saying the blood pressure is doing as we go through the capillary bed? It's what? Decreasing. Okay, now, how many cells thick is a capillary? One cell thick, okay? So that means when you have two cells, like a junction of two cells, there could be a little space there, yeah? So in that capillary bed, when the blood pressure is strongest on the arterial end, what it's going to do is the force on that blood, you've got a cut, right? If you've ever seen a really bad cut, it could even surge like a squirt. That would be bad. But the blood pressure is higher on the arterial end, so when it comes in, that forces fluid, the fluid part of your blood, to go out of the walls of the capillary bed and go bathe the cells around it. So fluid starts to come out right here, okay? Not the actual, okay, fluid's coming out. Not actual red blood cells or white blood cells. When that's happened, it's because your capillaries have been damaged. Maybe you got hit, and what do you have as a result of that hit? That's when all the stuff comes out. That's what a bruise is, when all the stuff comes out. You're normal. Are we walking around bruised? No, okay? That's because only the fluid part, the plasma, is coming out. And there are things in that plasma, nutrients and gases, right, that need to get out to those cells. So where does more fluid go out? At the arterial end or the venual end? Where did you tell me the blood pressure was the highest? So where do you think more fluids go out? At the arterial end. So more comes out here, then less and less and less and less and less. Do you agree with that? Now this should be a problem. You should be thinking in your head right now. But Miss Litton, you should be ready to ask me a question. If all that fluid goes out, how are we going to get it back? Exactly, so let me tell you why. Do you remember when we talked about diffusion and osmosis? Water must flow from the hypo. And it flows from the hypotonic side of a membrane to the... Is there stuff in our blood? Yes. The stuff in your blood is saying, come in. You have something called your osmotic pressure. Your osmotic pressure is this line right here. Your osmotic pressure says to come in. The osmotic pressure stays about the same. Oh, whoops, sorry, I'm a pen. Your osmotic pressure, okay, I'm still a pen. Your osmotic pressure stays about the same all the way through your capillary bed. Your osmotic pressure says come in. So look here at the arterial end. Who has the loudest voice? The hydrostatic pressure due to your heart, your blood pressure, or your osmotic pressure? Who wins at the arterial end? The hydrostatic. The out wins, forcing fluids out. But once we get to the venual end, whose voice is louder? Osmotic pressure, and it says come in. Now, sometimes you push more out than comes back in. That's what these lymphatic vessels do, is they pick up the extra. Okay? And they'll return it to your circulatory system after they've cleared it for service by sending it through some lymph nodes. Sending it through your lymph nodes because that's where your policemen of your body are monitoring. And we're going to learn about that in the immune system, so put a pin in that. But right here, I want you to look at the difference, and I want you to talk about it using this diagram right here. And I want, not it, take the lead on it, pass or play, pass or play. Okay, so at this end, the arterial end, the hydrostatic pressure due to the, what picture do I have in there? The heart, the blood pressure is highest, the hydrostatic pressure, so fluid goes out, okay? But here, this is our recovery time. At the venual end, we get that fluid back in once we get to the venual end because the blood pressure has dropped so much and the osmotic pressure has stayed the same. Now, whoever explained that picture, it is now your job to listen and ask questions of your other bio buddy as they explain this picture, which is the same thing. Go. Check out the things they've got identified up here too. Okay? You should feel super smart right now. Okay? You should feel super smart because most people in the world do not understand that process, right? Think about this for a minute. What happens if you eat a lot of salty food? So there's a lot of salt in your blood. What pressure could that affect? It could affect more than one, right? Because if you have more salt in your blood, what's going to follow that salt? Water. So your blood volume's going to go up, so your heart's going to have to work what? Harder. But that'll be counteracted because the osmotic pressure will be higher, so you'll get to recover it, yeah? Okay? So different things can affect each of these. Exercise can affect each of these, because if you're working out, your blood pressure is going to be what? Higher, okay? And we'll go through this too when we talk about the immune system. On your notes, go to blood flow. Arteries. Why does blood flow through arteries? It's due to the force on the blood by the heart. The blood pressure falls the farther the distance from the heart. The blood pressure falls the farther the distance from the heart. Okay? Capillaries. It's an exchange as a result of two opposite pressures. The hydrostatic pressure, what is it screaming? Out. And it's due to the heart, and it's stronger at what end of the capillary bed? Perfect. Arterial end of the capillaries. Forces nutrients, oxygen out. Osmotic pressure screams come in. Due to contents of capillaries, stronger than the hydrostatic pressure at what end? Venual end of the capillaries. Good. All right, the next part you already know. Okay, you know about veins. We talked about it at the start. Okay, blood flows due to skeletal what? You're not seeing my ginormous muscle, skeletal muscle. Contractions pushing on venual walls, valves, and breathing movements. Now, these valves look awesome. Okay, love these valves. So when it contracts, it goes up. If it falls back down, the valve, when it relaxes, these one-way valves keep the blood flowing what? In one direction. But what if your valves break? Okay, here's some evidence, claim evidence reason, okay, of some broken valves. When the valves break like that, then the blood can pool. That enlarged vein appears as a varicose vein. Now, there are all different kinds of varicose veins. There can be little spidery ones that are tiny. Those you're going to get as you age. I have little varicose veins, little spidery veins. Sometimes people have them really bad where they really stick out. I had a girlfriend who worked out. She was skinny. She was thin. She had terrible varicose veins starting when in her early 30s. She could never wear shorts because she would always be embarrassed because they just stood out on her legs like that. She always had to wear a long dress even if it was hot. Okay, so sometimes it's genetic and you're just predisposed to have those varicose veins. But there are things you can do that cause you to have varicose veins. Inactivity, right? Inactivity can cause that. Poor diet can cause that. Poor circulation because you have too much fat getting in the way. If you wear knee highs where it's tight right here or socks on your ankle, you know when you take them off when you have a mark? Okay? That means on the surface of your skin, okay, like a rubber band is right there, okay? then the blood can't get through because that rubber band is tight, and it can cause backflow right there and make you more prone to have varicose veins. That's why they'll be like right around here and right here at your ankles because of those socks. Now, is that saying don't ever wear socks? I'm not saying that, okay? You're gonna wear socks, right? But just be careful how tight those socks are. When you're sitting like this for long amounts of time, you should, while you're sitting in class, if you're not taking a lap, stretch your legs like this. Keep the blood flowing so it doesn't pool. Sometimes as a result of pregnancy, it can affect your blood flow and you can get varicose veins due to that. Varicose veins in your rectum are called hemorrhoids. Some can be internal like this. Some can be external. Some can be internal and they hang down so low you actually see them outside of the body. You can see the different stages of those. Okay? Thank you, Miss Litton. Thank you. Okay. No warning. No warning. Okay. All right. So go to varicose veins. You want me to remove that picture? It's like it's puckering up to give you a little kiss. Varicose veins. When I'm always sorry, inappropriate. I try to be good though. I try really hard. They can attest to that. I only swear like twice a day. When valves become weak and ineffective, hemorrhoids are varicose veins in the rectum. Varicose veins in the rectum. All right. All right. We're on the home stretch and we need to move quickly through here to finish up. So we're going to talk about blood contents. Now, your blood, if somebody came and took a little bit of your blood out of your body, not you, no vampires, but if you took a little blood out of your body and you put it in something that spins really fast, what do we call something small that spins really fast? Centrifuge. You'll have your formed elements that go to the bottom, like red blood cells and white blood cells, and then you'll have your plasma. Your plasma is about 50-55% of your blood volume. Those of you who don't have a lot of red blood cells, they will say that you are anemic. Okay, anemic. And the reason is the job of a red blood cell is to carry what for you? Oxygen. It's to carry oxygen for you. So if you don't have enough oxygen, it makes you weak and tired. A good way to get enough iron, because that's usually what you're missing, is to eat food that has like red meat. That will help you get enough iron. But if you're like, I'm a vegetarian, okay, you eat dark leafy green vegetables. Cook your food, your dark leafy green vegetables, in a cast iron pan. That can actually increase how much iron you have in your blood. But what I want to focus on right now, just for the moment, is the blood plasma. Because in your blood plasma, which is 90 to 92% water, you have all of these things that are dissolved in your blood plasma. Just read through them real quick. Got it? Okay, now, I'm going to teach you how to learn these. You're going to come up and scratch them off as I teach them to them. So stand up right there. I'm going over here. Okay, so no, yeah, I'll go here because you can look at the board that way too. I'm going to teach you everything that you would have in blood plasma. You ready? We got to think about going on a road trip. Let's say you don't have an electric car. So every once in a while, what do you have to do when you're on a road trip? Gases. Gases are in there. Is that on there? Cross it out. Gases, we got that? Road trip. You with me? Okay. Now, when you stop for gas, oftentimes you want to take advantage to go into the little store and get some snacks. So we're going to call that nutrients. Is that on our list? Okay, I've got to cross that. Sometimes when you go into that and get your snack, you're trying to make a good choice, so you might get a bar. Protein. There we go, protein. But sometimes you can't help it. You need some chips or something like that because they have what? Salt. So, look over here. Look away. What are the first things that are dissolved in the plasma? Think road trip. We stop for gas. We get some nutrients, protein, salt. Okay, we got 4 of them now. Now, while you're there stopping for gas, getting a snack, your parents might say to you, hey, do you need to? And when you go to the bathroom, you're going to get rid of what? Waste. Nitrogenous waste. Now, you just happen to stop at a poorly lit truck stop, and when you walk in there, you see a whore taking her vitamins or his vitamins because you need to stay healthy to pay your way through law school. All right? So hormones, vitamins. All right? So you got it down. I know, totally not appropriate, but you're never going to forget. Look at me, not the board. Did we hit them all?
Yeah.
Yeah, you don't even need the board. Look at me. We know inside our blood, we have red blood cells. What's their job? Carry oxygen. White blood cells, what's their job? Fight. Good. And we know we have platelets. Do you know what platelets are for? Blood. Perfect. You're golden. Golden, pony boy. Now, all those formed elements sit in liquid. The liquid is called what? And plasma is mostly water. But what's dissolved in that water? Well, there are, do it in order, gases, nutrients, do it with me, proteins, salts, nitrogenous waste, hormones, vitamins. Boom. Forever. Okay? Yes, I appreciate that support. I feel you. I feel your love. Okay, go to your blood contents. Formed elements in plasma, which is over 90% water. Plasma contains dissolved, can you fill it in? All right. Red blood cells contain hemoglobin and functions in what? Oxygen transport. White blood cell, its function is to something your body. What do you think that could be? Perfect. Protects your body from invasion. Now, some can be phagocytic, where they will eat like foreign things, okay? And others will produce antibodies. And others do cell-to-cell combat. White blood cells are like doing jiu-jitsu in there. Okay, platelets are all about blood clotting. There's a series of reactions like here. If you are cut, okay, the platelets will try to clot it. If it's a really deep cut, you might have to apply a little bit of pressure. If it's a really, really deep cut, you might need to get some stitches, okay? And I just want you to see it's like prothrombin triggers this, which triggers this, which triggers this. And eventually you get these fibrin threads that go across, and the red blood cells get stuck in them, and that becomes a scab. So platelets, I gave you A, I gave you B, part of B. Platelets at a wound with damaged tissue start enzymatic process, ending with fibrin threads forming a framework or clot. Hemophilia is an inherited clotting disorder caused by a deficiency in a clotting factor. Okay, don't do this. Okay, the more you know. All right, hypertension, high blood pressure. High blood pressure. Atherosclerosis, say that word. Atherosclerosis. We've already talked about this. We talked about it on the first day. Plaque buildup on arterial walls. A stroke. Stroke has to do with your nervous tissue dying. It's the reason why the nervous tissue would die is because it wasn't fed by a capillary, but it's really death to part of your brain cells. So a portion of brain dies due to blood clot or vessel bursting. A heart attack is a cramp in your heart, right? So a heart attack is a blood clot in a coronary artery. Blood clot in a coronary artery. Okay, and aneurysms, look, see how it's ballooning out like that? That's bad, okay? And if it ruptures, that's bad, okay? So an aneurysm is a ballooning of blood vessels. Ballooning of blood vessels. All right, and that is the end. Yay! But listen, give me a second. When am I going to review this chapter? What time? Lunch. Because if you're thinking about AP Chem, it's at 7th period tomorrow over there. Let's zip, pack, and put away so we can go see the Fine Arts Assembly. I totally forgot we were recording. And I recorded.
When you were saying that, I was like,